Hi, so winter is almost upon us. Yes, CAT 2022 is just round the corner. Keeping this in mind, we know each and every one of you is really excited but is also looking for the last final push and the fillip that is going to add those extra 5, 10, 15 percentile to your final CAT score. Well, because of this, BYJU'S exam prep brings to you the last lap to CAT 2022 starting on the 17th of October all the way till the 20th of November. Yes, 4.5 intensive, in fact almost 5 intensive weeks of preparation. What more, the focus is predominantly going to be CAT, which means, as we know, time, speed, distance and time and work in totality have almost equal weightage or sometimes even more weightage than geometry. So can we go ahead and leave geometry and just focus on these two? Can we go ahead and leave entire theta para jumbles and still score a 99.99 percentile in verbal? Yes, we can. This and much more in terms of preparation, in terms of intensive questions that we're going to look at and the smartest way of going ahead and solving that. So catch us on the BYJU'S exam prep app, and in case you missed that, on YouTube. But go ahead, download the BYJU'S exam prep app and also get a 99 percentilers kit which is going to help you ace CAT 2022. See you soon.
Hello friends, how are you? I hope all of you are doing good. Welcome back once again to the YouTube channel of BYJU'S Exam Prep. Most of you would know me, I'm Gaurav Gupta, and today I'll be helping you with the cheat code for the topic of algebra, right? So quickly confirm if I am clearly audible and visible to all of you. Good afternoon everyone, good afternoon Varun. So please quickly confirm if I am clearly audible. I'm waiting for your confirmation. So as soon as I'll get a confirmation from your side that I'm clearly audible and visible to you, we'll quickly start with this session. Harika, good afternoon. Prajwal, Varun, thank you. So friends, welcome back once again to our next session in the series of sessions that we are conducting for all of you for your preparation for CAT 2022. I'm pretty sure that all of you are moving on a right path towards CAT and the other MB entrance examinations. You are taking out good amount of time for the preparation of this examination. And if I'll talk about preparation, so I can say that most of you must have completed a lot of things. Most of you must have completed the entire syllabus. Now you must be like in the series, in the mode of the test series. So every second or third day you must be taking mock papers and analyzing these mock papers, thereby understanding what mistakes you are committing, finding out your weak areas and working on them. So these are the last 20 days in which you can polish yourself so that you will not commit whatever mistakes you are committing in these mock papers at the time of the examination. All right, so these are some things that you need to take care. Also, what you can do is the areas where you are committing mistakes again and again. So make sure that you are noting down all these things on a piece of paper and keep reminding yourself about these mistakes so that they will not be repeated at least on the day of CAT. Okay, so make sure that you are doing this thing. So friends, today the title of this session is cheat code for algebra. Now what do we mean by cheat code? Today in this session we are going to discuss some of the important formulas that we must remember till the last moment of the examination. All right, this is one thing. And then I'll also be taking on some of the concepts through questions, definitely, wherein we can save plenty of time in looking at or in understanding the direct approach of doing those questions. All right, so this session is going to be very interesting for all of you. We all understand the weightage of algebra in CAT. So definitely we know that this is one area which has the maximum weightage after arithmetic. There have been some instances in CAT in the previous years when the weightage of algebra and arithmetic was similar. So you can easily expect 30 to 40% of the questions to be coming from this entire area of algebra. And there may be some concepts, there may be some questions on which we tend to waste 2 or 3 minutes. right? So I have selected a handful of those concepts, okay, and I'll be explaining you those concepts with relevant examples, and will be telling you how you can directly save time in those questions. Okay, so there might be some questions which we can finish in less than 30 seconds, and using conventional approach you are using more than 2 minutes to solve those questions. Okay, Varun is asking, sir, mocks can be taken daily or they must be at a gap of 2 days for analysis. Now, Varun, if you're taking a mock today, then definitely you might be taking 3 to 4 hours for the analysis. Fine. Now, what do you mean by analysis? Analysis is not just knowing the mistakes. Analysis means after knowing the mistakes, I am working on those mistakes. So if you think that you can work on all those mistakes, you can improve on the areas on which you were a little weaker on the previous mock that you have taken in a single day, then it's fine, you can take the mock every day. But I believe, personally I believe that if I've taken a mock today, then I might take somewhere around 1 or 2 days for an improvement to work on those areas, and then after 2 days, that means the third day, I can take another mock. All right, so definitely not suggestible to take mock every day. Trump Tatya is saying, sir, quant में LOD 1 तक सॉल्व कर सकता हूं, मुझे LOD 2 में कॉन्फिडेंस नहीं आ रहा, क्या करें? Okay, now Trump Tatya, why you're not getting confidence, why not gaining confidence is just because of lack of practice. Okay, so there is only one reason why I am not sure about the questions which are in LOD 2. Okay, so there is only one reason, the lack of practice. So if you start practicing these questions, if you'll practice enough number of questions from LOD 2, then definitely you'll be comfortable in these questions and you can move towards LOD 3. So the only one single mantra to be confident in the questions of quant is through practice. All right, so make sure that you are doing enough amount of practice. Okay, now friends, the topics that we can keep under algebra are surds and indices, equations of different types, functions and graphs, logarithms, progressions, maxima, minima, inequalities, modulus. All these areas are under the chapter of algebra, right? Now here I am starting with some of the important algebraic formulas that you must remember till the end of the examination. All right, so I'll quickly take you through all these formulas, and then we'll take you to some of the concepts and the questions that I'm talking about. All right, so first set of formulas are on your screen, related to a plus b whole square, a minus b whole square, a plus b whole cube, and a minus b whole cube. Now if you cannot remember the binomial expansion a plus b whole raised to the power n, okay, where you can get the formula of a plus b whole raised to the power n for any value of n. If you cannot remember this binomial expansion, then at least remember these four formulas. Okay, these four formulas: a plus b whole square, a minus b whole square, a plus b whole cube, and then a minus b whole cube. These four formulas are used at a lot of places. All right, then some other formulas which are based on these four formulas, right? Let's have a look at those formulas. So first one is a cube plus b cube. Now if you remember the formula of a plus b whole cube, a plus b whole cube can be written as a cube plus 3a square b plus 3ab square plus b cube. If you remember this formula, then it will be very easy for you to derive this formula. But understand, at the time, like while we are writing the examination, it is not suggestible to derive each and every formula. Don't you think that it will save a lot of time for you if you remember these formulas, if all these formulas on your tips? Yes. So at the time of the examination, if you start deriving these formulas, then definitely you'll not be able to attempt many questions as you want, right? So that is why it is always suggestible to have these forms of the same formula, the different forms of the same formula on your tips, and you can save time in the examination. Okay, so you can derive this formula from the above formula that I have written, a cube plus b cube it has there. So you can take everything on the left hand side, do the factorization, and then you can get to formula number 5. But always suggestible to remember this formula in order to save time. Okay. Now similarly, a cube minus b cube can also be derived from the formula of a minus b whole cube, but it will be better to remember this form of the formula. All right. Now moving further, a square minus b square is a plus b into a minus b. ये formula हम बचपन से करते आ रहे हैं, बहुत easy formula है. All right. Then the first two formulas that we have seen on the previous slide, a plus b whole square and a minus b whole square. So a plus b whole square plus a minus b whole square. So जो 2ab वाला component है वो cancel हो जाएगा and you'll be left with twice of a square plus twice of b square. Okay, so when these two formulas are added, then on the right hand side you will get twice of a square plus b square. Okay, similarly the difference between these two formulas, look at the formula number 9. Okay, so the difference a plus b whole square minus a minus b whole square. Now in this case the terms of a square and b square will get cancelled. Okay, and you'll be left with 2ab from the first formula minus and then minus 2ab from the second formula. Now minus minus will become plus and you will get 4ab at the end. Alright, so this is the formula for a plus b whole square minus a minus b whole square. Right? Now moving on to the 10th formula, a plus b plus c whole square. Formula is easy to remember, a square plus b square plus c square. These are the three terms that you will get, and then twice of ab, twice of bc and twice of ac. Alright, so again a very useful formula when it comes to the questions of algebra. Right? Now moving ahead, now this formula is used rarely, but whatever I have written below this formula number 11, this particular form, this particular variation of the formula is used at a lot of places. Okay, so I have like rarely seen the application, the direct application of this entire formula, a cube plus b cube plus c cube minus 3abc. Okay, I have not seen the direct application, but this particular thing, when a plus b plus c is equal to 0, this part when a plus b plus c is equal to 0, so I can say that the entire right hand side will be equal to 0. The entire right hand side will be equal to 0, and hence you can say that you will get a cube plus b cube plus c cube minus 3abc will be equal to 0. Now 3abc can be taken on the right hand side and you will finally get a cube plus b cube plus c cube will be equal to 3 times abc. All right. Now what is the usage of this formula? Let us understand. Now this formula can be used when you are given any expression of this type such that the sum of a, b and c is equal to 0. So it will be used to do the factorization. So a cube plus b cube plus c cube, if you want to write it in the factorized form, then it will be equal to 3 times a into b into c. I'll take an example for this. Okay, let's take an example. So let's say you are given 7 cube plus 5 cube plus, wait, 7 cube plus 5 cube minus 12 cube. All right. Or in the other manner, let's say you are given 12 cube minus 7 cube minus 5 cube. Okay. Now this particular thing can be written as 12 cube plus, now negative sign can be taken, can be absorbed in the cube. Okay. So I can write it as minus 7 whole cube and then again plus, and I can write it as minus 5 whole cube. All right. Now in this case, you can see that a plus b plus c, where a is equal to 12, b is equal to minus 7 and c is equal to minus 5. The sum of a, b and c is equal to 0. Yes, 12 plus minus 7 plus minus 5 is equal to 0. Right. So this entire expression can now be written as 3 times a, which is 12, into b, which is minus 7, into c, which is minus 5. Or I can write it as 3 times 12 into 7 into 5. Both negative signs are absorbed. Okay, Fine. Okay. Now, Gulshan, focus on the things that I'm explaining you and forget about my French beard. Okay. So 3 times 12 into 7 into 5. This will be the factorized form of 12 cube minus 7 cube minus 5 cube. All right. So at a lot of places, you may get a question that this particular expression will be divisible by which of the following options. All right. So if I have written the factorized form of this 3 times 12 into 7 into 5, so this expression will be divisible by 5 as well as 7 as well as 12. Okay, and then you can select among the options. Am I clear to each and every one of you? Right. Okay, so this is one place where this formula number 11 can be used. Remember that today I'll not only be telling you the formulas, but also the usage of the formulas with the concepts and the questions as well. All right. Okay. Now moving ahead, there is a next formula, next important rule that can be very helpful in the questions of algebra. Okay. Now, first of all, I'll explain the rule and then I'll take an example for that. So the rule is, if you are given that a raised to the power x is equal to b raised to the power y is equal to c raised to the power z, and a into b is equal to c. So both these things are given to you. A raised to the power x equals b raised to the power y equals c raised to the power z. And the bases, the relation between the bases is the product of two of these bases is equal to the third one. So a into b is equal to c. Then we can say that the relation between the powers will be 1 upon x plus 1 upon y is equal to 1 upon z. We can easily derive this relation by assuming like the first expression, all of them as k, and you can easily derive all these things. I'm not here for derivation. I believe all of you would understand the derivation. I'm just making you understand the rules here. Okay, so if this portion is given to you, then you can directly say that 1 upon x plus 1 upon y equals 1 upon z. So if I look at one of the direct applications, so in a question it is given that 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z. Okay, now instead of ABC, I have written the numbers. 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power z. Okay, right? Good, Prajwal, good. So lovely to see some of you responding and writing the answers. If you know all these things, I hope, I suggest all of you to mention, to write all these numbers or the formulas in the chat box. Okay. All right. So now here 2 raised per x is equal to 3 raised per y is equal to 6 raised per z. This is given to us. Now the second relation, which was a multiply b is equal to c. This is not given, but it is clearly mentioned here. It can be derived from this numbers that 2 into 3, the product of these two is equal to 6. Okay, so I can say that the second thing which was given earlier in the formula is now not given, but it is understood that 2 into 3 is equal to 6. So now I can write the relation between x, y and z, that 1 upon x plus 1 upon y is equal to 1 upon z. Now this is the direct application. Now obviously you will not see the question in this form. थोड़ा सा twisted form में question होगा. So let's have a look at a twisted form of this question. ठीक है? So in the question you are given that, look at the top right hand side of the screen. In the question you are given that 4 raised to the power x is equal to under root 3 raised to the power y is equal to 216 raised to the power z. Now directly I cannot say that 4 multiply root 3 is equal to 216. No, it is not. But if I look at like a number whose power is 4, so I can say that 4 is a power of 2. Then root 3 can be converted into 3 and 216 can be written as a power of 6. So again, I can convert it in the form of 2 multiply 3 is equal to 6. So I just need to make some changes in the bases. So 4 can be written as a power of 2. So 4 raised to the power x will be written as So all of you can please mention the final result. I'm deriving it very slowly. So 4 raised to the power x can be written as 2 raised to the power 2x. Further, root 3 can be written as 3 raised to the power half. So it will become 3 raised to the power y upon 2. And further, it can be written as 216 can be written as 6 cube. So 6 raised to the power 3z. Okay. Now, I can see that 2 multiplied 3 is equal to 6. So the relation between these powers will be 1 upon 2x plus 1 upon y upon 2 is equal to 1 upon 3z. So this will be the relation that you will get. Arvind Kumar, good to see, lovely, very good. So this will be the relation that we can obtain. Now you can make some changes in these relations according to the other things which are given or asked in the question and then get your final answer. All right. So this is one thing that you can see in your examinations. This is coming at a lot of places. All right. Fine. Now let's move ahead and look at the remaining other formulas. Now the next thing I'm going to take is linear equations and the special equations. Now I'll not be spending a lot of time on linear equations and would like to spend good amount of time on special equations. Okay. So first of all, let us quickly have a look at some of the basic formulas for linear equations. Okay. This is one thing that I had to cover. So linear equations एक बार देख लेते हैं and then we'll go to special equations and we'll spend time there. Now pair of equations are written in front of you. The conditions for unique solution, infinite solutions, and the no solution. These are the three conditions, and I hope all of you would definitely remember these conditions. So this is from where linear equations start. You will all remember these relations from your childhood. Okay. Now let's have a look at the most important thing here, the special equations. Now in special equations, finding the number of positive integral solutions is one of the areas from which we are constantly getting questions in algebra. Okay, so let's spend some time on one or two questions or one or two types of questions from special equations wherein we have to find out the number of positive integral solutions. So I'll take the general form first of all. Let's say the equation is 3x plus 4y is equal to 92. All right, 3x plus 4y equals 92. Now in this case, we have to find out the number of integral solutions. I'm sorry. Varun is asking, sir, similar equation can also be used in coordinate geometry to find the in center. Yes, Varun, you can do that. Okay. Now 3x plus 4y equals 92. We have to find out the number of positive integral solutions. So I'll give you a general idea behind these type of questions. Now for these type of questions, first of all, what we need to do is we need to find out just one, कोई भी एक positive integral solution find out कर लो. Okay, so start with finding one positive integral solution. Now that can be calculated by either putting x as 0 or y as 0 or maybe some other value. So a little bit of hit and trial will be required. Not necessarily you will get a solution for either x equal to 0 or y equal to 0. Not necessarily. Okay. Now in this case, I can see that if I'll put x equal to 0, then the value of y will be an integer. Let's do that. So if I'll put x as 0, the value of y will be 92 upon 4. That is 23. Okay. Now in every equation which has two variables, linear equation in two variables, we can always say that whenever the value of x will change by the coefficient of y, then the value of y will change by coefficient of x. Let's have a look at it. So I'm saying that whenever x will change by coefficient of y, which is 4, whenever x will change by 4, the value of y will change by the coefficient of x, that is 3. Okay, so whenever x will change by 4, y will change by 3. Now in this equation, you can identify that if you will increase x, then y will decrease. Okay, and vice versa, right? So if x will increase, y will decrease, and then x will decrease, y will increase. Okay, now in this case, since I'm looking for positive integral solutions, so x is equal to 0 is in one of the solutions. From here, I should be increasing the value of x. I'll not be reducing. No. So we will increase the value of x so that x will be positive. Okay. Now, if I'll increase the value of x by 4, so next value of x will be 4, then 8, then 12, 16, and so on. The value of y will reduce by 3. So the next value of y will be 20 corresponding to this, then 17, then 14, 11, then it will be 8, 5, and then 2, and after which it will go towards the negative sign. Okay, so now we'll have to keep on reducing the value of y until we get the maximum, until we'll get the minimum number which is greater than or equal to 0. All right, so now we'll stop here, because if I'll go beyond this solution, the value of y will become negative. All right, so I'll stop at this point, and now you can count the number of positive integral solutions. Now if I look at this solution, in this case the value of x is not positive. Okay, so this solution will not be considered. I'll consider 1, 2, 3, 4, 5, 6, and 7. So number of positive integral solutions will be equal to 7. And if you are asked to find out number of non-negative integral solutions, then in that case it will be equal to 8, because the first solution 0, 23 will be included. Okay, so there will not be 8 solutions if you are looking at positive integral solutions. Positive integral solutions will be 7 and non-negative integral solutions will be 8. Now this is one place where we commit mistake. So 0 is not a positive integer, 0 is a whole number or a non-negative integer, right? So be sure what is being asked in the question. Is the question is asking about natural number solutions or positive integral solutions, or the question is asking for whole number solutions or non-negative integral solutions, right? So you have to be very careful about this particular thing, right? So this is one place from where the questions are being asked. Now let's move ahead and look at the next type of questions, right? Now the next type of questions are of this type: 1 upon x plus 1 upon y is equal to 1 upon k. Okay, I'm just quickly giving you a shortcut method. Now if you will take LCM and take all the terms on one side and do the factorization, then the general form of the factorized equation of one of the equations that is written in front of you is x minus k. You can always do that, I'm telling you. So if it is written in the form of 1 upon x plus 1 upon y equals 1 upon k, so its general factorized form is x minus k into y minus k is equal to k square. You will see this thing always. Okay, so for example, if you have 1 upon x plus 1 upon y is equal to, let's say, 1 upon 12, then this equation can be converted and written as x minus 12 into y minus 12 is equal to 12 square. 12 square is 144. Okay, now the main question the main agenda is to find out the number of positive integral solutions. Now the number of positive integral solutions for any equation like this will be equal to the number of factors of this number, the number of factors of k square. Okay, Kaushal, you are saying your voice is having a bit of lag. Kaushal, it might be because like I'm on YouTube, and yes, from like this is a technical problem. I'll not say a problem, this is a technical thing, that there will be a slight lag in the voice. Okay, all right, so what I was saying is the number of positive integral solution for any equation like this will always be the number of factors of k square. Okay, k square के number of factors निकालने हैं and that will be the direct answer. So here 12 square is 144, or it can be written as 2 raised to the power 4 multiplied by 3 raised to the power 2. So this is the factorized form of 144, and the number of factors of this number will be 5 multiplied by 3, that is equal to 15. And yes, 15 is the number of positive integral solutions of the given equation. Okay, right? So what you can now do is you can save plenty of your time and write directly the number of positive integral solutions. Or if let's say this is one of the questions in which you will have to find out the integral solutions, so definitely you will require positive integral solutions, and then you can proceed from here. All right, so answer is 15. Now let's take this thing forward. Okay, now if let's say you have an equation, so earlier it was in the form of 1 upon x plus 1 upon y is equal to 1 upon k. Now let's say the equation given is in the form of let's say a upon x, a is any constant, plus b upon y is equal to 1 upon k. I'm taking an example for this. Okay, so let's say 3 upon x plus 5 upon y equals 1 upon 13. All right. Okay, now what will happen to this one? I'm waiting for your answers. Let's see what will you write in the chat box. Varun saying, sir, rather than making equation, we can directly factorize also. Obviously, Varun, that is why I'm telling you all these things. So why to make equation? I'm just writing the equation for your understanding, but definitely at the time of examination, you'll not write all these things. You'll not write the entire story, but just calculate the final answer. Okay. All right. Now, if you have any equation in this form, then this after factorization can be written as x minus a into k multiplied by y minus b into k is equal to abk square. Okay. So for this one, the equation that you have now, you can write it as x minus 3 into 13, that is 39, multiplied by y minus 5 into 13, that is 65. You can do the factorization, you will get the same result, is equal to, I can write it as a into k multiplied by b into k. So 3 into 13, which is 39, multiplied by 5 into 13, that is 65. Okay. All right. So this is how you can convert it. Am I clear to each and every one of you? Right. So in this case, once again, the number of positive integral solutions will be the number of factors of this number. Right. Now 39 into 65 can be written as 3 raised to the power 1 into 5 raised to the power 1 into 13 square. So the number of factors will be 2 into 2 into 3, that is equal to 12, and 12 will be the number of positive integral solutions for this equation. All right. So these are the two forms that you can now remember, and a lot of questions you will see coming up from this area. Okay. So now like when we used to take probably 2 minutes to factorize and then find the answer, now you can get the answer in less than 30 seconds. I hope all these things are helping. Pragya, there is no need to multiply these numbers. It will be better to keep these numbers in the factorized form. Don't multiply these numbers, right? Because you will multiply and then you will factorize. So it will be a double work for you. So always leave these numbers in this form. Okay. Because ultimately we'll have to factorize them, right? Okay, now let's move ahead. Not visible red, Pooja, I'll not use red color now, but Pooja, can you confirm if I should write all these things again? I'll take care of it in the next slide. I'll not use red color, but I believe this much is visible, and then I'll avoid using red color from next time onward. I'm sorry, like I like using different colors, so red color is one color which is which create problem. Yes, Prajwal can be used in time and work question also, but time and work we don't have to find out the number of positive integral solutions. Okay, so you get equations like this in the questions of time and work, but those type of questions are totally different as compared to these questions. Okay, all right, friends. So let's move ahead and look at the next thing. Now the next formula are from logarithms. Now I could have written all the formulas beforehand, but I would like to spend again some time on the formulas of logarithms so that you will all understand the usage of the formulas of logarithm. So it's not just cramming the formulas will help you in logarithms, it's the understanding of these formulas also that will help you in solving all the conceptual questions of logarithms. So let's spend time on these formulas of logarithm and understand how these formulas are derived. Okay? Now, my attempt will be, my motive will be to make things look easier for all of you. Still, like we have 20 days. Some of you might think that it's a bit late to understand the formulas of logarithm, but it's never too late when we are moving towards such a big examination of our life. Okay, so let us understand logarithms. No wonder, like you never know, these formulas will help you, these understandings will help you, and you'll be able to do one extra question in the examination. Okay, so देखते हैं. Yes, music core, I totally agree with you. When I was at your age, I also used to think logarithms is a difficult chapter. But when I get into the formulas of logarithm, when I get into the understanding of the formulas of logarithms, I understood that these formulas are actually very easy. Okay, so let's spend 5 to 10 minutes on the formulas of logarithm. Okay, now first of all, usage of formulas of logarithm. Now we have an expression, an equation like a is equal to b raised to the power c. Now in this case, I have written a in the terms of b and c. Now the same equation, if I want to find out the value of b in terms of a and c, it can be written as b is equal to a raised to the power 1 upon c. But in the same equation, if I want to find out value of c in terms of a and b, then I have nothing to write, but I have to use logarithms here. Okay, so now let's see what will be the use of logarithms in questions like this, in concepts like this. Okay, now what logarithms are nothing but a function, a property. So if you remember the formulas of sine a plus b, ट्रिग्नोमेट्री हमने किया था बचपन में 10th 11th स्टैंडर्ड में, साइन a प्लस बी का एक फॉर्मूला होता था which was sin a into cos b plus cos a into sin b. Okay, so we have seen the properties of the formulas of trigonometric functions. Similarly, we have some properties for the formulas of logarithms. All right, so let us start with some very basic formulas. Now you must have seen a lot of formulas in logarithms. I'll say that you don't have to learn, you don't have to cram all these formulas, right? Now in books, what they do is, let's say I'm giving you just an example. So let's say if you know the formula of a plus b whole square, you know the formula of a plus b whole square. Now using this formula, can you derive the formula of a plus b whole cube? Yes, a plus b whole square को a plus b से multiply करना है and you will get the formula of a plus b whole cube. Okay, similarly a minus b whole square का formula हम derive कर सकते हैं from a plus b whole square. So all these formulas are related. Similarly, the properties of logarithms are also related with each other. Okay, so I divide these formulas in two different areas, in two different categories. So I'll call the first set of formula as the star formulas. This is just a random notation that I use to make students understand. So star formulas वो formulas होंगे जो हर जगह पे use होंगे, which are the basic formulas. These are foundation of logarithms. Then the other formulas are the formulas which will be derived from these star formulas. ठीक है? So let's start this. So the first star formula of logarithms says that, understand this thing, log of a multiply b. Log of a multiply b is equal to log a plus log b. All right. Log of a multiply b is equal to log of a plus log of b. Right. Now I'll parallelly open a new slide on which I'll be writing the formulas which can be derived from this formula. Now if I have log of a into b as log of a plus log of b, then I can say that log of a into b into c can be written as log of a plus log of b plus log of c. All right. Also, I can write log of a multiply a as log a plus log a plus log a. All right, that means it can be written as 3 times log a. So this one, log of on the left hand side, log of a cube has become 3 times log a. So whatever is the power of a, that comes and will get multiplied with log a, right? So from here I can derive another property, which is log of a raised to the power n is equal to n times log of a. So this is the first derived property. So we know the star property, the basic property. This is derived from that star property. Okay, so I'll write it separately now. Log of a raised to the power n can be written as n log a. All right. So this is not a new property, but this is the property that is derived from the first one. Similarly, I can write log of a upon b. Okay. Now log of a upon b. So it can be written as log of a multiplied by b raised to the power minus 1. Using the first property, I can write it log of a plus log of b raised to the power minus 1. Right? Now this minus 1 will come in front using this above property that is written on your screen. ठीक है? So minus 1 जो है आगे आके multiply हो जाएगा. So this will become log of a minus log of b. So log a upon b, it is equal to log a minus log b. This is also not a new property. This is derived from the previous property only. ठीक है? Fine. So हम इन properties को, like whatever properties that you have seen up till now, हम इन properties को अलग-अलग बना देते हैं, but these are one single property derived from this one. Log a into b is equal to log a plus log b. All right. So up till now we haven't seen any new property. Cool. आगे चलते हैं. ठीक है? Now I will come back to this expression from where we started. A is equal to b raised to the power c. Now if I take log on both sides, it will become log a is equal to log of b raised to the power c. So whatever properties I have derived up till now, I can write log a as c multiplied by log b, and value of c can be written as log a upon log b. Now make a note at this point, log a upon log b is different from log a upon b, right? So these two are different things. Make a note of it. So the next property says that log of a divided by log of b can be written as log of a to the base b. This is just a notation. This is just the way we write it. Log of a upon log of b can be written as log a to the base b. Absolutely, Jadev, absolutely correct. Right? So this is the second star property. Make a note of it. So ये दो property है. Now most of the properties in logarithms are based on these properties. There is no other property that you can see. Right? So ये दो properties remember कर लो, याद कर लो, and now you can derive a lot of properties based on this. So if I start deriving, I can say that log of a to the base a, log of a to the base a can be written as log a upon log a, which can further be written as 1. So log a to the base a will be equal to 1. All right, ठीक है? Next property देखते हैं. Log of a raised to the power b, and the base is I'm sorry, wait. Base is c raised to the power d. Okay, base is c raised to the power d. Now, the other properties, whatever properties we have seen up till now, the last one, this can be written as log of a raised to the power b upon log of c raised to the power d. ठीक है? अब a की जो पावर है ये यहां पे आके मल्टीप्लाई हो जाएगी एंड c का पावर विल कम हियर. Okay, so it can be written as b upon d. B will come in numerator, D will come in denominator, multiplied by log of A upon log of B, log of C, I'm sorry. Okay? So B upon D as it is, then now it can be written as log of A to the base C, right? So whatever you have, log of A raised to the power B, base is C raised to the power D. This b and d will come in numerator and denominator, and rest other things will remain as it is. So b upon d log of a to the base c. This will be one of the formulas, one of the important properties of logarithms. Right? Am I clear? Now similarly, there is another property that is used at a lot of places. A raised to the power log of b to the base a. Yes, can you all tell me what can be the simplified form of this formula? Anyone? What will be the simplified form of this formula? Now the important thing to note here is this particular thing and this, they both are equal. So this will be equal to b. Okay, if you have anything in the form of 5 raised to the power log of 28 to the base 5. So this will be equal to 28. Okay, so yes, all of you are absolutely correct. This is equal to b. This is equal to 28. Okay, so these are certain formulas of logarithms. If you will remember and will practice somewhere around 10 to 15 questions, then also I can say that if a question of logarithms will come from the level of difficulty of easy to moderate, then you'll be able to attempt those questions. Okay, so just spend 1 hour. If you haven't done logarithms, spend 1 hour on logarithms, look at the properties, look at 10 to 15 questions, and then you can enter the examination hall with a good amount of confidence that you'll be able to at least do easy to moderate level of questions from logarithms. ठीक है, चलिए आगे चलते हैं. Now next is maxima and minima. A little bit of maxima minima quickly. Now I'll be taking specifically two types of questions of maxima minima. First for quadratic expressions and the second one for modulus. Okay, the questions of maxima minima involving modulus. Sir, I have one doubt that division of log in properties will be subtraction. Okay, now Varun, I'll quickly make you understand. Yes, so Jaydev has just mentioned. So Varun, log of a upon b will be log a minus log b. Okay, this is a separate property. Log a divided by log b. This is a separate property. This can be written as log of a to the base b. So these are two different things. All right, Varun. So I hope I have cleared your doubt. वैसे जयदेव ने भी respond कर दिया था. So these two are different properties. Okay. चलिए आगे चलते हैं. So let's have a look at maxima and minima. Okay. Now first of all, maxima minima of quadratic expressions. Now let's say you have a quadratic expression. F of x is equal to ax square plus bx plus c. Now in this case, the value of a can be either positive or negative. Okay, depending upon the value of a or depending upon the sign of a, we can decide whether the graph of this parabola will be an upward opening parabola or the downward opening parabola, right? So if a is a positive number, then the graph will always be an upward opening parabola. Okay, and if the graph is upward opening parabola, then the maxima of this function will be infinity the maximum value of this function will be infinity, and there will be a finite minimum value. Okay, so there will be a finite minimum value, and we can find the minima of this expression. I'll come to this thing once again. Okay, but before that, let us understand if a is negative. What will happen if a is negative? Now I'll repeat the previous one. If a is positive, then the graph will be an upward opening parabola. Since this is an upward opening parabola, upward ये ऊपर infinity तक जाता रहेगा. So maximum value will be infinity, and there will be a finite minimum value. Alright, what will be that finite minimum value? We'll come to that in a few minutes. Okay. Second is, if a is negative, then the graph will be a downward opening parabola, right? So नीचे की तरफ ये infinity तक जाता रहेगा. So we can say that the minimum value of this expression will be minus infinity. Okay, and the maximum value of this expression will exist. Okay, so maximum for this will exist, and the minimum value for the previous one will exist. Cool. Now both the maximum or the minimum value of the expression ax square plus bx plus c will exist for some value of x. That value of x will be how much? The value of x will be minus b upon 2a. So what you will do is minus b upon 2a, calculate karo. That will be the value of x, for which the function will be either maximum or minimum. Get that value of x and then substitute that value of x in the expression to obtain the maximum or the minimum value of the expression. Alright, let's take a few examples for this. Jaydev, absolutely correct. Akhil, good. Okay. Alright. Now, if you have ax square plus bx plus c, this is the function. So let me write it's like one of the examples. So let's say you have x square minus 4x plus 8. Okay, this is the expression. Now here a is 1, which is positive. So this graph will be an upward opening parabola. Since it's an upward opening parabola, maximum value of the function will be equal to infinity, and we will be finding the minimum value of this function. Now minimum value of this function will exist when x is equal to minus b upon 2a. Okay, so minus b upon 2a, calculate kar lete hain. Minus of minus 4, that is plus 4 upon 2, that is equal to 2. So at x equal to 2, the function will attain its minimum value. Okay, at x equal to 2, the function will attain its minimum value. अब हम यहाँ पे एक mistake कर देते हैं कभी-कभी. We are asked to find out the minimum value. We get the value of x and mark it as the answer. No, this is not the answer. If we have to find out the minimum value of the expression, this expression, now put x as 2, and then the value that you will obtain will be the minimum value. Yes, Akhil, directly we बोल सकते हैं minus d upon 4a. Yes, you can take that. Okay, so at x equal to 2, let's find the value. So 4 minus 8 plus 8. So the value is the minimum value 4 or anything else? Yes, it will be equal to 4. So the minimum value of this expression will be equal to 4. Alright, so this is one way you can find out the maximum or minimum value of a given quadratic expression. Okay, now let's turn our focus to the last thing of this lecture, the maxima minima of modulus, of some of the questions involving modulus signs. So I'm giving you a question. Let's say y is equal to modulus of x minus 3 plus modulus of x minus 7 plus modulus of x minus 11 plus modulus of x, नहीं यहीं पे रुक जाते हैं, modulus of x minus 11 की जगह I'll write modulus of x minus 13. Okay, so let's say this is the question. Now we have two things to determine in this question. Number 1, the minimum value of y. Number 2, at what value of x the function will attain its minimum value. Okay, so first of all, we'll have to find out minimum value of y and then find the value of x for which it will be minimum, or vice versa. You can find out the value of x first and then substitute that value and then find the value or the minimum value of this expression. So I'll give you 30 seconds. This question is of not more than 10 seconds. I'm giving you 30 seconds to get me both these answers. No answer up till now? Okay. Now for this type of question, what you can do is you can start by plotting a number line. It's totally up to you. You may draw the number line or not. It's totally up to you. Okay. Now look at the nodal points in this expression. So the first modulus will be 0 when x is 3, second 7 and third is 13. So these are the three values, 3, 7 and 13. Arrange these three numbers in the increasing order, right? Okay. Now if these number of points is odd, number of points is odd. Here I have 3 points. If the number of points is odd, then this expression will attain its minimum value at the middlemost point. Number of points odd hai, so there will be only one middle point. Okay, right? So out of these 3 points, जो भी middle में है, at that value of x, the function will attain its minimum value. Alright, so I can say that at x equal to 7, the function will attain its minimum. Okay, so x की तो value आ गई, second question का answer आ गया. Let's see what will be the answer for the first question. The answer for the first question can be calculated in two different manners. One is put the value of x in this expression. So if I'll put the value of x as 7, so wait, I'll remove this. So if I'll put x as 7, the first modulus value will become 4, second will become 0 and the third will become 6. So 4 plus 0 plus 6, the minimum value of this expression will be equal to 10. Alright, so minimum value will be 10 at x equal to 7 and a lot of you have given a correct answer. Another way of finding this minimum value of the expression is looking at the distance between these 2 points. The 2 points at the extremes. So 3 and 13 के बीच का distance कितना है? It is equal to 10 and that will be the minimum value of this expression. ठीक है? Let's look at one more question of the similar type when the number of points is odd. So the question is, y is equal to modulus of x minus 5 plus modulus of x plus 7 plus modulus of x minus 3 plus modulus of x plus 2 plus modulus of x minus 9. So these are the 5 moduluses separated by plus sign. You have to find out the value of x at which the function will be minimum and then the minimum value of this expression. Two things I'm looking for. Archit, you can be like you can wait for some time, right? So abhi even wala karenge. So definitely like I want all of you to understand what will happen when the number of modulus is odd. So definitely I'll be coming to this example also because I've already bifurcated it into odd. So definitely I'll be covering when the number of modulus signs is even. So don't worry. Yes, any answer. So Amrit has given the answer. Amrit, I believe you have just joined. No. You have given a lot of answers earlier. I just missed your messages. Okay. So Amrit says 3 and 16. Kunal says 5 and 25. Sejal says 3 and 23. Different answers I'm getting. Okay. Now, Obviously, first of all, you will have to go according to what I have told you. हम important points भूल जाते हैं, ठीक है? So सबसे पहले इनको increasing order में arrange करना है. So the points are 5, -7, 3, -2 and 9. Okay. So सबसे छोटा point है -7, then -2, then 3, then 5 and then 9. Okay, these are the points. So the middlemost point is 3. So at x equal to 3, the value will be minimum. Okay. Now you can put the value of x as 3 and you will get the answer. Otherwise to find out the minimum value of the expression, find the distance between the extreme points. -7 and 9 के बीच का distance कितना है? It is equal to 16 plus the distance between the next 2 points. -2 and 5 के बीच का distance कितना है? 7. So the minimum value of the expression will be the sum of these distances. So 16 plus 7, that is 23, will be the correct answer. Okay. So Amrit, if you have more than 3 points, so you just have to keep on adding the distance between the extreme points, then the next 2 points, then the next 2 points, and so on. You keep on doing. Okay. Am I clear? So the correct answer here will be equal to 23. So 3 is the value of x at which the expression will take its minima, and 16 plus 7, that is 23, will be the minimum value of this expression. Okay. All right. Now let's move ahead and look at the next thing, when the number of modulus is even. So Archit, this will be specially for you when the number of moduluses are even. Okay. Okay. So let me write an example. So these are the 6 modulus signs that you have. Okay. No Jaydev, not average. Okay. Let's have a look at this one. So I'm explaining you the entire process, right? Now here what we need to do is, first of all, we'll again create a number line 1, 2, 3, 4, 5, 6. Now the leftmost point will be -4, then -2, then it will be 3, 6, 11 and 13. Okay. Now first of all, the expression will attain its minimum value in this particular case, or in case whenever there are even number of moduluses. So in the previous case, there was a single value of x. Understand, listen carefully. In the previous case, when there was odd number of moduluses, the minimum value of the expression was at a unique value of x. Okay, but in this case, the minimum value of x, the minimum value of the expression will be obtained for a range of values of x. So just select the middle 2 points. So you can always say that the expression will attain its minimum value when x will be from 3 up till 6. So 3 से लेके 6 तक कोई भी value होगी, including 3 and 6, the expression will attain its minimum value. All right, understood? So 3 से लेके 6 तक कोई भी value, right? Now let's find the minimum value of this expression. So minimum value again can be calculated by looking at the extreme points. Look at the distance between them. It is equal to 17 plus the distance between the next 2 points. It is equal to 13, and then the distance between these 2 points, it is equal to 3. So 17 plus 13 plus 3, that is 33, will be the minimum value of this expression. All right. So this is how you can directly get the answer of the questions of this type. All right. I hope you have understood this. Archit, I hope I have given an answer for your question, for your problem. So this is it. This is the best possible way, the most efficient way you can find the answers to these type of questions. All right. So I hope you would have enjoyed today's session. Definitely, I'll be coming back again and again with a lot of sessions like this. If you have liked this session, you know what you have to do right now. If you like this session, quickly press the like button. I can see very less number of likes. There are more than 60 students right now in the lecture, but only 50 likes. That is not acceptable, friends. So come on, quickly press the like button and tell me what all things you are looking for before your CAT examination, and probably I'll come up with any of the sessions as per your suggestions. Okay. All right. So friends, that is all from my side for the day. Now, a few important set of information for all of you. Now you can join us for the detailed live exam analysis on 27th of November 2022. So we'll be coming live for the detailed analysis for each and every slot at the mentioned timings on this screen. Okay, so all of you can join us live. Also, I must tell you that we will also be live on the YouTube channel with the first impression immediately after the examination is over. So immediately the slot 1 is over. Slot 1 will be over at 10:30. So we'll try to be live as soon as possible after 10:30 to basically discuss about the pattern of the examination that has come in slot number 1. That will definitely help you. Yes, Education Word definitely will try to come up with some variety of questions for LRDI as well. All right. Next is any student who is preparing for CAT 2023. This is a comprehensive program that we have started for all of you. On the screen, you can find the details related to this program. So you all can join our CAT 2023 program. Already a lot of batches have been launched for CAT 2023. So don't delay this process to start your preparation for CAT 23 and quickly join these programs. All right. Dipankar, yes, I got your name. So Dipankar, LRDI, definitely I'll come up with some questions. Sejal is asking, sir, in mock, I'm able to attempt around 36 marks in easy moderate papers. So what should I do? Sejal, practice. So Sejal, I have made some videos in which I have explained how to do a proper analysis of the mock. So with the proper analysis of mock and working on your mistakes, you will definitely be able to increase your score in whatever days you are left with. Okay. All right. Now, one important thing, if you have exhausted with any of the test series that you are using and you want to buy another test series, so you can buy this test series offered by BYJU'S Exam Prep, which will definitely help you in these remaining days for CAT and definitely for the other entrance examinations also. Last lap to CAT 2022 will continue. These sessions will continue to be telecasted live at 7 o'clock on every day starting 17th October. It has also started, but now they will be conducted on every day up till 20th of November. So please do join us. Okay. So Varun, you're saying, sir, in log there are some questions of APGP, so that becomes a worry. So Varun, if you think you understand that these questions will become worry, these questions will create problems for you. So I'll suggest that whatever things you think that will create a problem, you still have 20 days. You can spend half an hour or 1 hour on all these types of questions, and then they will not bother you anymore. Okay. So that's all from my side, my dear friends. Thank you very much for being a part of this session. I'll definitely come back to you once again with another set of questions, with another set of concepts. Till then, have a good day. Bye-bye.